In this chapter, we're going to explore basic geometric figures, and in these figures, we're going to have angles. And what we're going to do is convert angles from degrees to maybe degrees in minutes. So let's start here with this one, 40.7 degrees. Let's express this in degrees in minutes. Now, here's what we're going to have. There's a conversion factor here. We have 60 minutes is equal to 1 degree. And then we can even go further. We could say 60 seconds is equal to 1 minute. Now, maybe remember, but way back in chapter 2.1, we did some conversions, and we wrote those conversions as fractions. Let's do that here. So if we divide both sides by 1 degree, we can say this. We can say 60 minutes is to 1 degree. This is equal to 1. And then also here, 60 seconds is equal to 1 minute. That's equal to 1. But then we can go the other way also, depending what kind of conversion we want to make. We could say that 1 degree is to 60 minutes. That's equal to 1. Or 1 minute is to 60 seconds. That's equal to 1. And let's take a look now at this problem right here. We already have the 40 degrees. What we want to do is take the 0.7 degrees and convert that from degrees to minutes. So we're going to have 0.7 degrees. We want to convert this to minutes. So here's how we were doing those problems out of 2.1. We took 0.7 degrees over 1 times, and then we did a conversion factor. Now what we're going to do here is multiply by 1. And you remember what we did here? We want degrees to cancel and minutes on top. So let's look at these converters here. We want degrees on the bottom. So here's a converter times 1. Here's a converter, 60 minutes to 1 degree. So let's multiply by 60 minutes to 1 degree. And then the degrees cancel, and we get 0.7 times 60 minutes, all over 1 times 1, which is just 1. We're going to say that 40.7 degrees is equal to 40 degrees and 42 minutes. Now, in this problem, we're going to go backwards from what we did in number 1. In number 1, we had 40.7 degrees, and we converted it to degrees in minutes. And now what we're going to do is we're going to take 142 degrees 15 minutes and convert it back into degrees only. So let's just take a look at this 15-minute part here. What we want to do is we want to take 15 minutes and convert that just to degrees. So let's write our 15 minutes over 1 times, now here's our converter. We want minutes to cancel, so we're going to want minutes down here in the bottom and degrees in the top. So look for a converter over here that has minutes in the degrees in the top, minutes in the bottom. It's going to be this one right here. Degrees in the top, minutes in the bottom. So our multiplier will be this. 1 degree is 60 minutes. The minutes will cancel, and we're going to be left with 15 times 1 degree over 1 times 60. So we end up with, now 15 times 1 is just 15 degrees over 60. And making that division, we get 0.25, and we still have degrees. So now we are going to conclude that 142 degrees 15 minutes is the same as 142.25 degrees. So let's use this in problem number 3. It says find the measure of the supplement of a 72 degree angle. So we might have something like this. Here's maybe what we're thinking. Here's a straight angle, a line. We have an angle here that's 72 degrees. Now we're looking for the measure of this angle. And if we call this angle x, we know that x plus 72 degrees is equal to 180 degrees, right? Because they're supplementary. So if we subtract 72, we will get x equals 108. So the angle we're looking for here is 108 degrees. Problem 4, we're given this right triangle. I know it's a right triangle because here's our notation for a right angle, a 90-degree angle. And what we're asked to do is just identify and determine the length of the hypotenuse. So in any right triangle, the hypotenuse is the side opposite the right angle. Here's the right angle. The side opposite is this one right here, and its length in this case is 25 inches. In number 5, we're given this parallelogram. Now what we know about parallelograms, actually this is given in the book here, some information in the book. In my book it's on page 203, but it says a parallelogram's a quadrilateral. There's our 4 sides, quadrilateral, in which both pairs of opposite sides, like this side and this side, are parallel. This side and this side are parallel, and opposite sides have equal measure. They're the same length. So this side and this side have the same length, as do this side and this side. Not only that, but opposite angles have the same measure. So angle A, measure of that angle is the same as measure of angle C, and the measure of angle D is the same as measure of angle B. And what we're asked for in this problem is to find the length of DC. Well, because it's a parallelogram, and parallelograms have the characteristic that opposite sides have the same length, AB and DC are opposite sides, so the length of DC is going to be 5 centimeters. And now here in problem number 6, we've got a circle, and here's a diameter. We're told that the diameter is 11.6 centimeters, and what we want to do is find the radius. So in a circle, you have a diameter, and the radius is half of this diameter. So we know this, that the radius is equal to half the diameter. So we're going to have 11.6 centimeters divided by 2. And when I compute that, I got 5.8 centimeters. Now in this problem, we're given that the angle between, how about BTW for between, the angle between a ray of light. Now here's what a ray is. A ray is something that's, you have a kind of a line segment that starts at some point and moves out. It's not an entire line, right? It just starts here and goes out. That's called a ray. So what we have is that the angle between a ray of light and a line perpendicular to a mirror is 78 degrees. What's the measure of the angle between the ray of light and the plane of the mirror? Let's draw this, see what we can come up with. So first of all, here's a mirror. Here's like the shiny surface over here. So here's a mirror, and then we have a line perpendicular to the mirror. Let's draw that. So draw a line perpendicular to the mirror. Okay, here's a line perpendicular, so that makes a 90-degree angle. All right, so here's what we've got. Here's a mirror, the shiny side here, and here's a line perpendicular to the mirror. And what we're given is that the angle between a ray of light and a line perpendicular to the mirror is 78 degrees. So suppose here's a ray of light. Maybe it comes in here, and it goes up right to here and hits that line. And I guess this angle here would be 78 degrees. And what the problem's asking us is, what is the measure of the angle between the ray of light and the plane of the mirror? So, you know, I gotta tell you, this seems like an oddball problem to me. It just seems like what we're gonna do is we're gonna take this line here, this ray of light, move it over like this so that it hits the mirror like this, this is still going to be our 78 degrees. And then this angle, this is the angle between the ray of light and the plane of the mirror. Now remember, this is 90 degrees. Do you remember complementary angles? Two angles are supplementary if they add to 180, but two angles are complementary if they add to 90. So what we're looking at then is that this angle right here, that's going to be 90 degrees minus the 78 degrees, which is going to give us 12 degrees. In the last problem we're going to do here, we want to find the length of the diameter of the circle. Now apparently this is a radius line, and what we know is that the diameter is twice the radius. So we know this, that the diameter is 2 times the radius. So this diameter is going to be 2 times, there's calculator notation, 19 centimeters. So we're going to say that this diameter is 38 centimeters in length.